sound ridiculously first, but the longer I talk, the more rationally it's going to appear.
This is a fun little video I thought I'd walk you through.
It's August 1972, and Ian Richardson, a future NASA scientist, is watching TV when the BBC announces
the interference is caused by solar activity.
He didn't know it then, but the sun had just erupted in one of the most powerful solar events ever recorded. There was no threat to humans because Earth's magnetic field deflects much of the sun's radiation.
First thing I'm going to point out with this video, I just want to make clear. Okay, so these particles, these are solar energetic particles. This is a consistent, this is not the coronal mass ejection that just occurred that they're talking about. This is just a consistent. This is our bow shock. The magnetosphere is invisible. There's a very fine, thin layer right here that is all the layers of our atmosphere. All in my previous video, I explain all of it. This is the entirety of the Earth's atmosphere, consolidated to showing all layers, including the tropopause, the mesopause, stratopause, the mesopause, so on and so forth. This explains the temperature differences between each of those points. This here represents the entirety of the Earth's magnetosphere and the various bands within it. The blue within the plasmasphere right here represents all of the entirety of Earth's atmosphere. Earth's atmosphere stops at the end of the blue and is only confined and contained through the magnetosphere. The moon is the size of the tip of my pen, and it is 230,000 miles out. 230, now remember, 620. This is 25,000 kilometers, or 25,000 miles out. So if the moon was, say, back here, we could go all that distance, it would be here. This is where the moon would be. And they never have the moon ever shown in a graphic. Aside from that, these particles are not to scale, and that's what I wanted to make the point. They will talk about later. However, note that they're going to completely disregard electromagnetic reconnection points, which I touched on in my first video.
Field creates a protective bubble that shields us from highly energetic particles that stream in both from the sun and interstellar space. As the solar wind bathes our planet, Earth's magnetic field lines absorbs this energy and gets stretched. And like elastic bands, they eventually release energy by snapping. As a result, particles in the region are flying at supersonic speeds. That burst of energy is magnetic reconnection. For the first time, magnetic reconnection was detected in the turbulent magnetosheath, the boundary between the magnetosphere and solar wind. This region is made up of turbulent plasma. It's one of the most chaotic regions in the near-Earth space.
But the explosions were so powerful that intense radiation disrupted TV signals and caused...
Now see, it caused the problems because in these bands, at the very end, there's a neutral point where electromagnetic points happen, and it ends up coming in through various polar cusps.
Magnetic reconnection is one of the key forces driving particles to accelerate through space, and it's a fundamental driver of space radiation, a critical phenomenon to understand when protecting our satellites and astronauts.
There's already publications from GSI, Princeton, Berkeley, and I think a couple from NASA that I have linked in my previous video that are all talking about the amount of particles and the weight of them, the speed of them, and all of that. I know that UCLA and Anik covers the speed and weight of the majority of them from the chromosphere all the way through space to our bow shock, and then I know Princeton covers a lot of the magnetosheath and everything. There's the reconnective point, electromagnetic reconnective points that are within the first layer. So down here is that inner Van Allen belt. Now this is also inaccurate. There are 3 Van Allen belts now. Australian astrophysicists found a 3rd one and reported this about 2008 to 2012, and so it hasn't been updated with NASA's books, but occasionally they do mention it. So there's a 3rd one that's down in there, and that's actually the one that's going through the mesosphere. That's we have one that's starts about 1,000 feet, and that's the one that's started right here. So of course, while we're flying very low in this thin area, about 230 miles up, we will come in contact with the one that's 1,000 miles up at some of the polar cusps whenever we're making the long transitions around the north.
Like a
and south
capacitor,
poles.
the planet takes in and releases energy to and from the ionospheric layer. It is the energy there that enters and makes its way down through the atmosphere in columns of the global electric circuit, only to return back up to the region and either recycle or be
So they
part of
touch
the-
on, astronauts need radiation protection when they're in these parts of the area. However, they're always in the lower cusp, and it's only because of the neutral points allowing the reconnection to happen so that they fall through the polar cusps where it actually affects all of these lower areas. And underneath all of the International Space Station's passage down there in the mesosphere, just above the third band, but well below this 1,000-point band, that's in the mesosphere is where we have most of our communication satellites. All of them then, most of them now. We have a lot of exosats now where we're shooting them still within the underside of this band, but some of them are doing long loops. Most of these heliophysics satellites that he's going to talk about here, these are the ones that I love the most. However, you'll find that Ben Davison's and many other astrophysicists have pointed out there's nothing outside of the bow shock. That's why we can't measure the entirety of the magnetosphere. We're just measuring points of, and that's why we're just understanding the electromagnetic reconnection problem. And solar energetic particles is the difference between the coronal mass ejections as opposed to galactic particles from cosmic background radiation, which is another thing they're going to touch on. So here we lose communications because 1% of that 1% makes it through. So 1% comes through, 1% of that hits the neutral point, reconnects, goes through polar cusps, makes it to the lower levels, and then radiates the inner Van Allen belts, this outer one here and the inner one here. And so that, when we're passing through, we get the 1% of what's left of that. So we get 1% of 1% of what's outside of here. However, you saw from the earlier graphic, there's a great number more than that 1%. So we're safe down here, we can't be out here. Something I touch on thoroughly in the other video. Their graphics obviously are better. So,
Just
continue.
radio blackouts. So what if you were outside Earth's magnetic field? On the moon and beyond, astronauts face the risk of extreme radiation exposure.
GSI has covered this.
And I was wondering, maybe to both of you, what are some of the challenges that you see coming up in spacesuit design, especially as we think about going to Mars and maybe on to some of the moons, like increasingly hostile environments in space, and dealing with problems of ionizing radiation to astronauts over long periods of time? So I'm just interested in what your thoughts are in that direction.
It's a good preview question for, I think, what we're going to hear about, but go ahead.
Yeah, go ahead. You can go first, I'll go second.
Well, as I had said, the first thing you do is you have to look at the mission. The jump from Gemini to Apollo is very important because the astronauts had to walk. Now with the ISS, the astronauts don't have to walk, so the lower half of the suits are not very mobile. So everything goes to mission. As far as radiation is concerned, that is a concern, and I think David is probably better trained to answer that.
Low weight suits, very low mass, very mobile. That's where the future we think of design and development. Radiation is maybe the #1 showstopper to keep our astronauts healthy and well. Don't think it makes sense to incorporate that into the suit design. It makes sense to incorporate that into your shelters and things like that, because you need a very high dense, high massive protection of the radiation. So I kind of decouple the two, thinking about the suit and life support system design and then your habitat and rover design, which are better equipped to do the radiation protection.
Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field, This is a beautiful image that you see, what you see here, this one is a human cell. This is a human nucleus, so you know it's 10 microns approximately, and these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space but not on Earth, except in Darmstadt at GSI where we have it, going through the cells and making damage to the DNA.
Now, the particle that GSI used is what is found in the magnetosheath. It is It is just inside of the bow shock. However, it is just on the cusp of being outside of it. That's why Marco Durante, the lead physicist for all particle research in Europe and the world now, has made it very clear that these particles can only be found in those areas or in their lab, and that to resist them you have to have a genetic structure that is exactly the same as like the Hulk, because you have to be made of these heavy elements in order to survive the penetration these heavy elements will do. Otherwise, the free radicals, the heavy ions, will knock your electrons off your own existence and you'll just fall apart, you'll decay. It'll be disgusting, it'll be like, oh, going down and getting some Ebola and coming back, you know, it's cancer at its finest. That's why Apollo 13, we really tried to go for it in that inner Van Allen belt we were just discussing in the first one, 1,000 feet up, they got really close up to it. 2 out of 3 of them, even though they came back with the best radiation treatment ever, they died. In the same radiation, by the same cancer that GSI, Marco Durante, showed that would happen. So, how can we protect them? If you look at the previous video I made, you'll show links at the bottom of it that state very clearly, to protect the astronauts you need the active shielding, electromagnetic shield, static shielding, whatever you want to call the Earth's magnetosphere. You need one of those on your crafts or on the shielding that is the suits in order to survive the consistent particles. Now what this video is going to continue doing here is going to try to make everyone aware of solar energetic particles and the consistency of it, however downplay the consistency of it while up-talking coronal mass ejections, and that they are the same as a solar mass or a solar energetic particle, being that they're just a lot more of them. However, you'll notice in the graphics there's always going to be a thin haze. Well, that's the constant light, the constant heat, everything that we have that is the radiant environment that the sun is producing. Now our bow shock pushes off most of that, and how we survive is because we're using the 1% of the 1%, and we're kind of like, we're created a greenhouse effect with our atmosphere, and so we're surviving because of it. But at the same time, too much of it will destroy the greenhouse. Too little of it will turn into an ice ball again, or too much of it, it will completely just thaw us out, and we'll lose most of our particles and become Mars. Everything will be dry ice, and all the life will just die. It's all because of carbon and nitrates and various things that everyone that's denying climate change knows about. Which is another reason we're having a hard time with climate change, is all the water isn't raising in the sea as we lose the ice on the land, because they're neglecting to mention that, well, you know, particles come in, particles leave as well. So we're losing oxygen and helium and hydrogen at a phenomenal rate, and so these things together make water. So we're losing water as fast as it's melting off. That's why the seas aren't rising, but they can't really say anything about that until they come out with this. And this is like looking at your feet through, you know, a little, scope that will tell you your shoe size. Eventually we have to come out with, this is bad for you, this isn't how it actually works. We did some duck and cover shit again, and we're going to let you know why it's not really functional and possible now. This is some more of them talking about the presentation that they put out back in GSI about these guys needing active shielding, and this is a warm-up introduction.
Luckily, the intense radiation in 1972 occurred right between the Apollo 16 and 17 missions, when no astronauts were in their path.
So, if they were in the low atmosphere and trying to figure out, you know, the 230 to say 500 mile range, because during that time, we had just figured out the mesosphere travel. You know, John Glenn went around and, you know, like, whoa, yeah, first American in space and all that good stuff. Made it like, 200 miles the first time, then went around. But meanwhile, like, Yori went all the way around. So Russia had figured out how to get all the way up to 230 miles. However, the rest of the world was, still like, okay, so if we all work together, we'll figure out how to, we stole a bunch of people and we figured out how to get in the thermosphere. So, unfortunately, by the later Apollo missions, when we realized don't hit 1,000 miles up because fucking our ionized tanks can't stop it, you know, we tried it again with the 2014 Orion launch, and without the tanks this time and no people, and the ionization up in the upper Van Allen belt.
My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before. As it punches into Earth orbit, Orion will jettison its launch abort system. The upper stage of the rocket fires again. Like the setup for a roller coaster ride, this is the big climb we've been waiting for. We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
Still well within the thermosphere, not even outside in the exosphere. It blew up our systems, and they ended up losing communications with it, just like they lose during, and there was no solar storm, it just happened because solar energetic particles in the upper bands. There's a greater amount as you go up, and it's not just going through them really fast, because again, like the graphic showed in the very beginning, there's more outside than within. It's just within, it's bouncing around, and occasionally one of those hits us. That's where, like, there's not many in space, and so it's okay up there. And it's true, because there's only 1% of the 1% where we are. And then you start to get the 1% of the 1% that comes through, which is 99% greater for us, because we're only getting 1% of that in the lower band. So obviously that's when we started having problems. Orion failed, we brought it back down, we haven't launched it since. We refused to put people up there again, since we'd almost lost them in Apollo 13, and Russia lost who knows how many people. They just keep that shit quiet. They're always perfect, everything's great, right? So we're at least, slightly honest that, oops, yeah, shit happened, but hey, we did it. And so, we kind of stopped, leveled out at about 230 miles, and we figured out that, well, as long as we're right there, and as long as we're figuring out how to do basic shielding while we're right there, and we come down like every 30, 90 days, sometimes 6 months, a couple of, times, Russians are down doing it for a year. We did that, Scott Glenn, or whatever the fuck his name was, he did it for a year, and then now Russia's doing it constantly for a year. So, maybe we're figuring out with our new water shielding how at the lowest levels, in that 1% of the 1%, we can use shielding, which we'll touch on earlier. I watched the original Orion, the girls putting the stuff over. I made a nice little video, it's on my page as well. I posted the Bert the Turtle thing after it saying duck and cover, because that shit only works when you're inside the Earth's magnetosphere.
Duck and cover.
Holy moly. All right. Hi, my name is Jessica Voss, and this is Anne McLean, and we are here today helping the designers of the Orion capsule evaluate the ability to protect their crew from radiation. Radiation, as you know, is really harmful, and so the whole point is for us to get into a really cool little shelter and take all the equipment we have in this capsule and put it over us as best as possible. And we have to make sure it's stowed and that we are safe and we have everything we need in terms of supplies down in this awesome little bay.
Yeah, going to space is hard and going to deep space is harder. And the technologies that we're going to need to successfully get to Mars have been being developed for many years, and it's going to take many tests like this one over many years by a large group of people in order to make that mission successful in the 2030s. So we're excited to get there, and we're working every day.
Shielding, passive shielding can be a solution on the planet, but not really on transit.
Now tell me right out loud, what are you supposed to do when you see the flash?
So even if they launched out and went really fast as they're showing here, they're just going further in. However, we know now at this arch and this angle, we just watched the new India mission launch their communication satellites, and we got an almost consistent view all the way up. 9 minutes it takes to get within the upper mesosphere and be safely within, the ability to launch the secondary, and boom, then be on your way to the thermosphere. Russia's figured out how to do it in a few hours now if they time it just right, lining up with their people. Back in the late 60s and early 70s, though, it took us days to finally figure out how to safely get to that 230-mile mark and not go too far up and get ionized, but not fall back down too fast like our earlier missions, Gemini and Mercury. So, finally, when they figured this out, yes, of course, they wanted to make sure that they weren't up there during when one of these coronal mass ejections would come through, because that's when 1.9%, a greater amount of the particles would come through our bow shock and hit the neutral point, come through the polar cusps, and blah, 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 radiate down on us right where they're going to be at. And yes, water, lead, lots of, some transitional metals do work, but only within the active shielding that is the magnetosphere, another thing that Marco Durante touches on. So, we'll continue.
As NASA plans missions to go back to the Moon and then onto Mars, predicting the Sun's activity to protect astronauts from space radiation is one of our biggest priorities.
One of the biggest unknown factors about going to space is the radiation hazard from the
I
sun.
know him.
This is Ian today, studying the effects of the Sun, also known as the field of heliophysics.
The sun is always emitting radiation, like the light we see, but certain energetic particles, like from the August 1972 events, can be far more harmful.
So, first thing he said, that's the truth. And that is how they're going to get away with not exactly stating, they're not being dishonest, they're just not filling everything in accurately. Now they're going to use relative terms. And now it's because they just stated the very clear. It's always radiating. That's just the light, you know, the heat, the stuff you see, those are just particles, you know? It doesn't hurt us. Except Marco Durante has shown us what all of the particles that are out there are. It's just whether there's a greater amount and whether they move at a greater speed. Now, when the alpha waves finally break, and there's a great deal of confusion as to why those specific alpha waves break as they do, the magnetic causes or electromagnetic reasons for those breaking down, and I can discuss the heliophysics with people all day long. I'll just be quoting Ben Davis and a bunch of other people just constantly because they're smarter than I am. So. The bottom line, we don't know exactly why that happens, but when that happens, yes, there's a greater amount. However, they're not a heavier particle, and UCLA's Annika covers it within the 10 GeV Sun lecture. If you look up that, you'll find that she states exactly why it is that the chromosphere actually causes, because of the Sun's magnetospheric bands, certain areas outside of it, for them to consolidate, become denser, and as well faster, sometimes with up to the speed of light itself. So, there's a great number of physicists that have talked about and shown exactly why it is that what they just touched on there, and the fact that they have shown and completely proven that the consistency is the same as the anomaly that allows the greater amount to be released. That is why he had to state that at the very beginning. Although it's constant, you know, these things are also, they release a greater amount, and greater is a relative term there, and there is a greater number of them. It's not a greater particle.
To be able to forecast solar energetic
More is
particles,
just more dangerous.
we need to know how the Sun energizes them. The Sun is made up of electrically charged particles called plasma. As this plasma moves, it builds up energy inside its massive magnetic field. This energy is usually released in two types of explosions. Flares are intense flashes of light. Coronal mass ejections are giant eruptions of solar material.
Neither of those are the cause of the consistent solar energetic particles. However, coronal mass ejections and solar flares, both of them contain solar energetic particles, as they're all the same. However, the amount the two different ones release and the reasons for them releasing are completely different. I mean, we can get a greater amount of X-ray from an Earth-facing quiet than we can from two, sunspots. So there are a great number of reasons why all these are different. So here's them explaining.
Eruptions send shockwaves across the solar system, accelerating particles as they do.
These are solar energetic particles, or SEPs. They consist mainly of protons.
Okay, so before this mass of solar energetic particles ends up hitting us, take note of the consistent solar energetic particles. Now, stereo, all of these, everything are taking wild swings within and outside of the exosphere. However, everything is within the bow shock and the magnetosphere. This is a constant truth shown always by their stories and their claims, such as even the Voyager, which is just now hitting the bow shock, and we're losing contact with the
stellar wind. The magnetic field spins opposite directions on the north and south poles, creating a sheet where the two spins meet. This sheet gently ripples as it travels outward, and the ripples get bigger as they go. When this sheet reaches the termination shock, it starts to compress, like water waves hitting a wall. The Voyager spacecraft have now found that after the termination shock, these stacked up ripples of magnetic field form bubbles, shown here as a computer simulation. This discovery has prompted a complete revision of what the heliosheath region looks like. The smooth, streamlined look is gone, replaced with a bubbly, frothy outer layer. This new layer also changes our understanding of how extremely fast-moving particles, called cosmic rays, enter our solar system. When they arrive at the bubble region, they slowly move from bubble to bubble until they can reach smooth magnetic field lines and follow them toward the sun. The nature of the bubble region explains why Voyager 2 has been seeing variations in the number of energetic particles compared to Voyager 1. Because of its path, Voyager 2 has been passing in and out of the bubble region. When it is in the region, Voyager 2 sees many trapped cosmic rays and electrons. When it is out of the region,
all of the stories they put out, same with the Kepler's happening now. We're losing contact with it. And every time we start to lose contact with these things, we flip them around and take a picture of Earth. Now the camera's back in Carl Sagan's days with garbage. So obviously, 25,000 miles out, you're going to get this tiny little dot, and that's exactly what it would be. What are those bands? What's all that stuff? Well, we had the ability to edit photos back then. So no, it's not Photoshop. It's photo editing, and it occurred for the same reason that we were talking about UFOs and shit like that. It's just, it's something that humans do. We fabricate tales and we lie. It's why the Bible exists. It's just, we do these things occasionally. Power, fame, profit, who cares? Anyways, so there's a consistent. There is going to be a greater number of all of the same particles. As everything's within the bow shock, here is it hitting, and it happens immediately. We get sometimes within 8 seconds and then up to 8 days, we get all variable amounts of gamma X-ray to alpha beta particles just ionizing all of our equipment in the upper atmosphere. So here is what it looks like when you're in the furthest regions of the thermosphere and sometimes dipping into the exosphere when things like this occur.
And possess a lot of energy that can affect satellite measurements and humans.
SCP. Now that was not a solar energetic particle consistent. That was a coronal mass ejection that released a great number of solar energetic particles. And that's what they're not letting you acknowledge. However, they are acknowledging. Now this thing, as they've shown many times, and as you saw in the graphic of this video, this thing would need that wonderful purple little shield over it, according to NASA. They have stated this because GSI has made it clear that you need a bow shock, just like the Earth's, in order to stop all of these solar energetic particles, as well as the really, really harmful ones that come from cosmic background radiation, or the greater amount from the solar flares and solar storms that are coronal mass ejections, things that are anomalies we haven't quite figured out and can't time. So we're based on luck when it comes to those, and that, you know, can affect us in the upper or in the lower atmosphere and destroys our equipment in the upper atmosphere. So if we want one of these, we have to create the active shielding or electromagnetic or whatever, the bow shock of the magnetosphere to go over one of these crafts.
These can bombard you with a lot of radiation in a short period of time. It can penetrate your skin, damage your DNA, and increase your chances of getting cancer and radiation.
This is a beautiful image that you see. What you see here, this one, is a human cell. This is a human nucleus, so you know it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space but not on Earth, except in Darmstadt, the GSI, where we have it, going through the cells and making damage to the DNA.
So you remember GSI? That is my main point consistently, because that is what their main point is. There is a constant speech from every single one of their videos now that is discussing why it is genetic research is the most important to understand space travel now. That's why Francis S. Collins and Kate Rubins, a non-military official, was allowed to be a part of the International Space Station. And she got to study there because the work she can do in biology would have assisted Francis S. Collins in making tissues that we are going to put on the new Ark mission and send into space. And for whatever reason that they're going to create news on it, it is a furthering study to what GSI and Marco Durante showed us. So, the best way for us to be able to understand everything that's happening here is through the genetic studies that they're talking about. Because every single one of those videos that Marco Durante has shown has a time lapse on it, and that time lapse is very specific. It is an instant, and with the amount of particles that Princeton shows, that their presentations consistently show a great amount of, even though it's not to scale, they show such a vast amount, and it would be greater if it were to scale. It would just look like light. And everything that is, we would have to fly in. That's why, you know, everything that we take pictures of has to be photo edited from our telescopes. It's just bright out there. The DNA is what we have to change, like Marco Durante said, in order to push past it.
But they don't occur with every solar eruption. Only a small number of flares and coronal mass ejections create SEPs.
So we're trying to predict when SEPs form and how they travel through space.
At NASA's Goddard,
they're always traveling through space. That's why all things have matter attached. That's why if you see a comet or an asteroid, a hail spot flying by, it will always have a tail, and the tail will always be pointing away from the sun, even when it's flying away from the sun.
Spaceflight Center, the Community Coordinated Modeling Center, or CCMC,
These are the
is
greatest tools
dedicated
we've
to
ever
testing
created.
prediction models. Working with global partners, they use data from NASA satellites at different vantage points and models to figure out how solar explosions behave, including how shockwaves energize SEP.
But take note, the consistent particles they do have to account for, because there is always matter. Space is not empty or cold.
And as we get better at predicting, we get more time to prepare.
Preparation for an SEP event, of which you may know that is already coming and perhaps a magnitude as well, the technique that you would want to use is to put as much mass between you and the source.
He knew just what to do. He's duck and cover, duck and cover.
Holy moly. All right. Hi, my name is Jessica Voss and this is Anne McLean, and we are here today helping the designers of the Orion capsule evaluate the ability to protect their crew from radiation. Radiation, as you know, is really harmful, and so the whole point is for us to get into a really cool little shelter and take all the equipment we have in this capsule and put it over us as best as possible. And we have to make sure it's stowed and that we are safe and we have everything we need in terms of supplies down in this awesome little bay.
Passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic
The leading
fields.
hypothesis is that the magnetic fields are blocking some portion of the solar wind from
The
reaching
solar
the
wind
surface.
is the sun's continuous outflow of particles and radiation that fills the inner solar system. Earth's magnetic field provides a strong global shield against it. However, the magnetic field on the moon is much weaker, and it forms only small, localized bubbles of protection. In these spots, the sun's particles can be reflected back into the solar wind or funneled to nearby regions. The shielded areas under the magnetic field form pale swirls. Those bordering parts become darker. The contrast is so prominent, we can actually see it from Earth.
The magnetic fields in some region are locally acting as this magnetic sunscreen. You know, sometimes you put on sunscreen and you miss like a tiny little bit, and then you have a really bright red spot on your skin where you missed it. That's in some ways the analogy of this sort of region of the moon that is extra exposed.
Unfortunately, the moon's patches of magnetic field are not robust enough to completely protect human explorers from the sun's radiation. But further study of lunar magnetic fields could lay the groundwork for future innovations.
Well, what if we got a strong enough magnetic field that perhaps we could produce artificially? That's a question that I think remains to be answered, but the crustal magnetic fields on the moon and lunar swirls kind of provide a hint in that direction that we might be able to learn something about.
On the surface,
Again, Marco Durante stated very clearly that mass, transitional metals, all of the passive shielding will only work within electromagnetic or active shielding, such as the bow shock, the Earth's magnetosphere. So you would have to create one in order to have the ability to leave ours.
of the moon or Mars, astronauts can go underground or build shelter with local materials. But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the
Again,
center of the
showing
spacecraft.
that we're only
Other possible
230 to
techniques in development
250 miles
include
out.
vests that add mass and electrically charged surfaces that deflect particles.
And electrically charged surfaces that deflect particles. And electrically charged surfaces that deflect particles.
Shielding, passive shielding can be a solution on the planet, but not really on transit. This is a beautiful image that you see. What you see here, this one, is a human cell. This is a human nucleus, so you know it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space, but not on Earth, except in Darmstadt at GSI, where we have it, going through the cells and making damage to the DNA.
Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
In terms of radiation protection and radiation mitigation, the factor of time is extraordinarily important.
The Sun has a natural 11-year cycle that transitions through low and high activity, which is indicated by the number of sunspots on the surface.
We all
More
saw
sunspots mean more eruptions, resulting in a higher risk
solar
for
eclipse,
SCPs.
and you'll see the
But during
consistent
this increased
waves that are
solar
coming off
activity,
of it.
the Sun's magnetic field
That's the solar
strengthens,
energetic particle
enhancing its
constant.
shield
That
against
wasn't a
another
chroma
of
mass
the source of
ejection or any
radiation,
of the solar flares.
galactic cosmic rays. These are charged particles traveling at nearly the speed of light that are thought to come from supernova explosions from within our galaxy.
These, again, are not to scale. This is an inaccurate representation. This is just an inaccurate representation. This graphic is flawed in all ways. Not only that, we aren't even sure exactly how the cosmic background radiation is affecting us.
And possibly further out in the universe. If solar energetic particles are intense...
So, here it is, perfect. Solar energetic particles. Now, it doesn't take the sunspots releasing any extra particles for there to be this consistent. Now, they make it very clear that when, you know, these break down and these alpha waves snap and release a heavy amount of these particles, there's a greater amount. And that greater amount weighs heavier on our bow shock, as they showed the constant compression of it. And then sometimes in the neutral points, some make it through, and that's how we have it. However, note, in all of their graphics, every single time, they make it very clear that this is constant. These are ultraviolet rays of all types and all densities. They are alpha and beta particles of all types and all densities. They are speeding at various rates at various points, and we can only theorize why. Continue.
Sporadic storms, then galactic cosmic rays are a constant drizzle. Galactic cosmic rays are more sparse, but also much more energetic. They include heavier elements that can penetrate through vast amounts of materials.
Holy moly.
Understanding the rate of galactic cosmic rays helps us determine how much time astronauts can spend in space safely.
It's a human nucleus, you know, it's 10 microns approximately, and these two lines that you see here are two iron
Today,
ions.
humans have only been on the lunar surface for a cumulative total of about 12 days. A trip to Mars will take 6 to 10 months each way. That means even more radiation exposure, and so NASA is doing work to prepare for that.
The moon is going to be a test bed for us in order to be able to prepare for Mars. The more that we understand the impact and the duration of radiation on the moon, the more we
I also want to point out that
extrapolate that to the length of time.
They're going out of their way to use all of these terrible graphics, like that looked like the Boston Baked Beans commercial with them, the guys on the moon running from that monster. Like, that's how bad those graphics were. This is NASA. They have the ability to do all of it. They constantly take pictures from the Hubble and various satellites, and they create them into these amazing pictures for all of us to love. The Horsehead Nebula is presented everywhere now, and we all know what that picture looks like. And it's not what that picture looks like. It's a CGI artist who by chemically coded areas, knowing exactly what elements would be what colors and the density, was able to create exactly what the cloud formations and everything would be to color. It's a beautiful art. I'm not knocking it. I'm just stating that that's what we're doing. And with the skills that we have to do this, this is being done for a reason. And the reason why this is being done is because when they have to release something new, in case they can't just tell you, we can't go, we're all gonna die here, and global warming is a main cause of this, we can't fucking stop it. We don't even know why there's a magnetosphere. We're like, it's an iron core, but at the same time we're like, well, look at all these other moons that don't have iron cores and have strong magnetospheres. What about like Uranus and Neptune? Hell, they don't have iron cores, or maybe they do, but the magnetosphere is like 30 degrees off its axis. Parts of the atmosphere are outside of the magnetosphere. How does any of that work? And the only logical theory that I can come up with, a hypothesis I should say, because I can't back with anything, and no one else is talking about it, is the magnetosphere already exists. That point of electronegativity already existed, and the matter, such as various things like the legend of Venus flying through our solar system and falling into its place, is just another fine example of maybe it already existed and these clumps of matter fall into orbital placement because they already existed. So that's just my nonsense though. I just find it interesting that we've chosen to do such terrible graphics to represent our great achievement and what is our greatest achievement. So,
Time that we will be spending in transit and on the surface of Mars.
So that's it. So I just wanted to point out that this is NASA's first step towards telling everybody that unfortunately the Van Allen belt people were right. And not that it's the Van Allen belts hold all the radiation. No, they just hold some of that radiation. Radiation we don't experience on Earth. However, it's just a minute amount. And that's why they get to say, there's not that much of it and we'll be okay in space. And yes, in outer space. However, outer space is, we leave the stratosphere and we go into the first steps of outer space in the mesosphere. And we watch that all the time. That's where SpaceX puts almost all of their stuff. And then occasionally, when they're going to the International Space Station, they have the secondary booster, and we watch that take off. And that goes from the mesosphere to the thermosphere. And that is hundreds of distance of miles. And so we're 230 miles up out there. The Hubble was about 350 miles up. That's the highest the shuttle's ever gone. And the ionization actually caused neurological damage to them, and they couldn't stay up there for more than 5 days and repairing it. And that's why it's floating away from us instead of us finishing it and it coming back down and us still being able to service it. That's why we're creating the James Webb. And we're creating it out of gold because gold doesn't ion. It doesn't have the oxygen properties. It's not radical. It's not going to be penetrated by the heavy ionization like all of the rest of the transitional metals we've been using. So it's not going to break down. It's not going to cause interference. We're going to get a better picture. We're going to get a longer signal. It's going to be good. I can't wait for it. It's going to show us the heavens even better than we could have imagined. Because everyone's going to call it the heavens until we die because, well, Mike Pence is a flat earther. Jim Bridenstine's a flat earther. These people follow the Bible to their truest detail and extent. They believe it. They think the earth is flat. They're the people running this organization. So this is propaganda. Everybody knows what's going on and why it's going on. There's nothing we can do about it. And when we figure out what a magnetosphere is and why it happens, or if we can figure out how to genetically alter ourselves so that we can survive further out, we're going to make a space station for ourselves. About 350 miles up, and control it with retrothrusters, ion motors that they're coming up with to use the ions that are around them to push it back down. Because Russia owns 230 miles up. They put their mirror there first when they got there first, and we met them in the last Apollo mission. And now we buy rides to go to where the last Apollo mission sent to for the Apollo 50th anniversary and launch from Russia with their crafts. And we can call it money. We can say that, oh, it's just easier this way. And then we can work our asses off trying desperately to figure out how to create the same system that was Apollo, that is the Soyuz, with the same escape systems that they've already used that now we're testing. Again, we're always behind them, and we're trying to get to where they were, except they're not going to let us on the next one, so we have to create our own, and so we're putting it just above theirs. We tried it below, so did JAXA. All of them tried it right below, but 200 below, you know, you fall down and fast, so it doesn't work. You have to go higher. However, if you want to go higher, got to change your body. You got to be able to protect your brain. And all of this passive and transitional metal isn't going to work. GSI showed why. Princeton, Berkeley, UCLA, they've all confirmed exactly what the problem is, how to fix the problem. Francis S. Collin, the guy who wrote the genome, the leading biogeneticist right now, is on it. He had Kate Rubins working in space trying to figure this out for him because he can't go up. All of these things are in mass effort, and it's a global effort. While there's this constant, race politically, because everything here is politically driven. That's why the first treaty was in '67. Nixon sent us to space. Then it was in '97. Now Trump's sending us to space. And we're gonna just keep. It's a constant cycle. Every single time we're working together to try to maintain and hold that area of space. Neil Tyson went off about how Stephen Colbert went off on how military dominance is what the space race was about. So if you want to end up owning everything, put all the stuff up there that you can. And he said it's absurd, no one would ever create weapons, and Russia created weapons to shoot down other satellites and own everything up there. They're kicking us out, they make us pay.
Tonight, new concerns inside the U.S. defense community over a Russian military satellite exhibiting some very strange behavior. Our Brian Todd is on the story for us. Brian, why are officials...
They own it. They finally took us out. It was a long game, it was beautifully planned, so we're fighting back. We're making Orion, we're going to put up our own space station. We're just calling Gateway not, what Apollo 17 said Gateway should be, and that's around the moon. It's not going to be around the moon. That's what they said last time, and then we built the International Space Station. So obviously it's around the Earth, because Apollo 17 said the International Space Station should be around the moon. they were going around the Earth. They went to where they were going around, and they built it exactly there where they went to and where they have been since. And why no one leaves that? Because genetic structures. So this is one step towards NASA coming out with what I found out, unfortunately, when I went to college and started studying chemistry and astronomy and physics, and I found the answer I was looking for. And why don't we leave Earth? Why can't we get out of here? Why are we fighting in the dirt for fucking pennies and primal materials? The cosmos is full of everything we need. Sagan was right. I was convinced for so long. Why aren't we out there? But I don't think we're going to. And here's all the reasons why, and they're slowly coming out with it. If you haven't seen my video about why we aren't out in space, it's on my channel. So just take a look at it. I called this a long time ago. I've been pointing this out for years when I first got into CERN and LIGO and GSI studies, and found that they're kind of the leading engineers to understanding if there was a God, if that word could be more than just how I feel, think, and exist, and the various emotions that come from my narcissism or my ego. Sure, they got the answers. I'm willing to listen to that at least. I've heard everybody else's stories. I'm bored. So, all right. I hope you enjoyed this hour-long presentation, and that's all I got.